In this problem, we have to draw graphs that meet the given criteria. We need a graph that's decreasing, but it also needs to be a function. To be decreasing just means as you move left or right that your graph is going down. To be a function, graphically, you can test whether something's a function just by applying the vertical line test. My graph is the graph of a function because if you were to draw a vertical line, it would hit no more than 1 point, meaning for a given input x, there corresponds only one output y, and it's right there, that point. And this would be true regardless of where I drew the vertical line. If I drew it here, I'd only hit 1 point, and only here 1 point, etc. On the next one, we are to draw a graph that is not a function, meaning that if you were to draw a vertical line, it would pass through 2 points. So you need only draw something like this, and that would not be a function because someone could draw a vertical line right here and hit 2 points. And what that means is there's an x value here, let's pick this one, that if you were to plug in that x value, you'd get out this point right here, which means you'd get this output. And if you plugged in this input, this point down here says that you would get this output. So here is an input that corresponds to 2 outputs. And the definition of function says that an input can only get mapped to only one, no more than one output. So this is definitely not a function. In this problem, we are to take f of x, this equation, and find the value of f of 10 and f of negative 10, and then finally write our answer in function notation, and don't forget to write it also as ordered pairs. So the first part, I'm given f of x, but then I'm to replace x, what's in the parentheses, with the number 10. So doing so would look like this. This x would be 10, and then I'm going to proceed to plug 10 in for all of the input variables. So this would be 10 squared minus 2 times 10. And then don't forget there's a subtract 15 at the end. If you simplify this, this would be 10 squared is 10 times 10, or 100. We are to subtract 20. 2 times 10 is 20. And then we are to subtract 15 after that. So if you do the arithmetic here, we have 100 minus 20 is 80. And then 80 minus 15 is 65. So if you copy the left-hand side down here, what you find that f of 10, and this is function notation, is 65. We plugged in 10, got out 65, and we're writing that in function notation. So that's one answer. But it also said to write our answer as an ordered pair. So as an ordered pair, that would look like this. With an ordered pair, it's always input, comma, output. So for our problem, the input is 10 and the output is 65. So this, what I'm boxing right here, is the same information as what's up here. This is point notation, this is function notation, but they mean the same thing. F of negative 10 is going to play out in a very similar way. You are going to replace x now with negative 10, and this would look like this. If you wrote negative 10 squared with no parentheses, by the way, that would be an incorrect way to write it. What this actually means, if you read it that way, is that the 10 gets squared first and then the negative gets applied, and that's not what you want to do, as this function says whatever the input is, square everything, including the sign. So if you were writing this on a calculator or even on paper, that would be incorrect. You need parentheses around this. And then you'd have subtract 2 times negative 10. I can indicate multiplication with just putting a set of parentheses here. And then we have a subtract 15. Simplifying down, left-hand side is f of negative 10. The fact that we're squaring this means negative 10 is being multiplied by negative 10, which gives you positive 100. This time you have a negative 2 times a negative 10, so we're going to get a plus 20 rather than a negative 20. So the answer is going to be a little bit different. And then don't forget you're subtracting 15 over there. Notice that 20 minus 15 is 5, and we're going to add 100 to that, so the answer is going to be 105. So in function notation, we have that f of negative 10 is 105, and that simply means if you were to input negative 10, you'd get an output of 105. So when you translate that to point notation, it looks like this, parenthesis, input, which is negative 10, comma, output, which is 105 in this case. Then you go from function notation to point notation. So my answers, there's, oops, 2 answers to this one. The answers would be this, and you would not be writing input and output there. What a messy, I'm just not going to box my answer. Number 3, given a function f of x is 8x plus 11, we are to find x. They're not, our job is to find x. They're not going to give it to us. So this is completely different than the last example, where the very first thing they did was give us the x value they wanted us to plug in. Not the case here. Find x. We're not going to give it to you. So this x is going to be left x, and we want to find x such that f of x, the output, that's this guy, we want f of x to be 3. So find the x value, him, that makes f of x 3, and then write your answer in function notation and as an ordered pair. So when I do this problem, it's this guy right here, f of x, that I'm going to replace with 3, the entire notation. Compare that with this example over here, where we were to evaluate the function at an input. So in this case, we were evaluating the function at an input of 10, and we replaced x with 10. This is completely the opposite. In fact, we wouldn't even be saying evaluate here. We'd be saying solve this equation. Whenever you're given the output, which we were, the output is 3. You are now solving, not evaluating. So notice I'm not plugging a number in for x because we're supposed to find x. That gives an output of 3. Once you realize that, the rest is pretty simple. You'll solve for x by subtracting 11 on both sides. And then on the left-hand side, 3 take away 11 is negative 8. On the right-hand side, you get 11 take away 11 is 0, and there's no need to write plus 0. Now, to solve for x, since the 8 is being multiplied, I'm going to do the inverse operator of multiplication, which is division. So I'm going to divide by 8. On the left-hand side, I have a negative divided by a positive. That's a negative. 8 divided by 8 is 1. On the right-hand side, I get the 8 divided by 8 is 1. So on the right-hand side, you get 1 times x. But since multiplication by 1 isn't usually written, I'm just going to write x instead. So I did the problem. I found the x value. Remember the directions, find x. So that if you were to plug x equals negative 1 in here, you would get out 3. In fact, you could check really quick that would be the case. If you were to replace x with negative 1, you'd have 8 times negative 1. That's negative 8, and negative 8 plus 11 does indeed give you 3. The last problem in this video is a table of data where the input is given to be x, and then the function notation here says that the output is k of x. So there's my function notation. Remember, k is just the name, it's not the function itself. It's all of this notation that represents the output variable. So given the function below as a table, first find k of 3. So we called the function k of x, and then we're asked to find k of 3. So if you just compare these two things, that means they're telling me that they want x to be 3, right? They're giving me the input x equals 3. So I need only go to my input row, find out where x is 3, and when I do that, going down, the table tells me that the output k of x would be 5. So this would be written one of two ways. K of x, the output, is equal to 5, and when does that happen? It's equal to 5 only when x is 3, and then of course we've adopted this notation that means that says we can shorten that. If k of x is 5 when x equals 3, then we can write it in a more shorthand notation and say that k of 3 would be 5. So if k of x is 5 when x is 3, we simply just replace the x with 3 in there, and it becomes this in function notation. Then as an ordered pair, of course, your input of 3 goes first, and your output of 5 goes second. On B, they want to go backwards. They want me to solve rather than evaluate. Find the x value, solve for x, so that the output would be 17. So notice there's two 17s in the chart. You need to discern whether the 17 is an input or an output. If you remember, my output variable is k of x, so they're definitely saying that the output here is 17. And what x value would create that situation? Look in the chart. Here's my output value is k of x. Where is k of x? Equal to 17. That's right here. When would that happen? Only when someone plugs in x equals 2. So the answer would be x equals 2. In fact, if you wanted to go one step further, if you were to replace x with 2 in this notation, it would say k of 2 is equal to 17. So there's a couple different ways you can say that, but one way is that the output is 17 when the input's 2, or you can simply say k of 2 is 17. So reread the directions to make sure we answered it. We found x such that k of x is 17. We wrote our answer in function notation, but we haven't written it as an ordered pair yet. But things haven't changed. As an ordered pair, the input goes first, then the output, which is 17. So there's my answer as an ordered pair. The last question simply says determine the domain and the range of k of x. And since I have a discrete set of data, meaning that there's only 5 inputs and only 5 outputs, none in between, there's only going to be 5 elements in my domain and 5 elements in my range. So my domain is simply going to be a list of those 5 elements, but we list them using these curly brackets. My domain would consist of -1, and I'm going to separate them by commas. 2, 3, 8, and finally 17. The range of the data, or any function for that matter, is just the set of outputs. So I'm going to put my curly brackets here. Oop, I forgot my curly bracket over here. Some people call these braces, but some people call them curly brackets. My range is the set of possible outputs, so you can list them in any order. Some people are insisting that you do so in starting with the smallest and going up, but that doesn't really matter. So one way to write your range would be 3, 17, 5, 0, and 62, and that is 100% mathematically correct. Now, some faculty may have you write the 0 first, then the 3, then the 5, then the 17, then the 62, but and that's fine, just as long as you know that mathematically this set of numbers is the same set of numbers regardless of the order that you write them in.